Welcome to Taxonomy Online Mathematics. This is episode 2 of Calculus, introductory part of it as limit. In the first video, we talk about the concept of limit. Now you want to think about the properties, the various properties of limit. We take some few ones and we zoom into calculation. Let's say we have addition and subtraction law. So for example, if I have a function, or let me use the word limit of a function, if I have this, the limit of this function, you can see we are performing addition or subtraction. So if I claim this, it means I'm referring to addition, and vice versa. This is going to be rewritten as the limit of the function f of x as x approach a plus or minus the limit of g of x as x approaches what? A. So what we do is that, you see, the limit is for the addition, but we find the limit of the first function plus or minus the limit of the second function. So if I have a function of this to be 3x plus 1 given to me, then the function of this also given to me as 4x squared minus 1, it means I am going to take the function of f of x, find its limit. If the limit is 2, it means I'll use 2 here and use 2 here. So find the limit of this separately, find the limit of this, then I perform the operation of addition or what? Subtraction. That is the first part of it. We also have that of multiplication. So if I have the limit of a function g of x times f of g, then g of x, all multiplying together, as we have our argument to be a. So how we did it for addition and subtraction, we do the same. You perform the limit on the first one. So limit of f of x as the x approach a times the limit of g of x as x also approaches a. So if you have any function, perform the limit on that function, perform the limit on the second one, then now you can multiply the values together. Alright, let's take it a step further. We have done addition, subtraction, multiplication. So let's see, we have that of a constant. So limit of a constant as x approaches a is just what? The constant. So if you are asked to find the limit of 5 as x approaches whatever number it will be, the answer is just what? 5. So because there is no x value to substitute the 7 to, this is having a constant. There is no x value that I can put the value of 7 in. So it's just the way it is. Now if you have the limit of a function x, only x, approaching as x approach a, in the beginning we mentioned that anytime you have a function, they substitute the value of x to the argument. So this is just going to be what? A. So if I have the limit of x as x approaching 2, it means my answer becomes what? 2. As the limit, the final answer becomes what? 2. That is for when the function is only the independent variable. Now let's talk about exponential law. If you have the limit of f of x, but the f of x is raised to a power n, what you do is that you find the limit of the f of x as x approaches a, then you raise it to the power. That simply means that if I have the limit of 3x squared plus 1 all raised to the power 3, where we have x approach what? 1. What I'll do is that I find the limit of this. I will slot in the value of what? 1 into this place. Whatever answer I will get. So I'll be having 3, 1 squared plus 1 all to the power 3. So in this case, I have 1 squared, 1. 1 times 3 plus 1, 4. So it means that I'll be having 4 exponent what? 3 as my final answer. So if you find the exponent of 4 exponent 3, then you can get your answer as the limit. So if you have an exponent, all you need to do is perform your limit, then use the exponent to operate to get your final answer. I think there is another one going to be limit of, okay, let me use the function for better. If you have this, what to do is that this is also the root law. So we know the n can assume number of 2, 3, 4. So if it is 2, square root, 3, the cube root. If you have this, it means you can still perform the limit. This is going to be of the function as the x approaches what? A. Then we have our cube root or square or fourth root of the number. So this is what we have. I believe there's a last one. Let's check. We have a limit of c and a function, okay, where x approaches a. The c here is a constant, multiplying it. So here it means I can take my constant out, find the limit of the function as it approaches a. If I like, find the limit, separate the constant from the function, then find its limit. When you are done with the limit, then you multiply it by the constant. So these are the various properties, or better still, the laws which we use in the limit of a function. Thank you. I'll do video on the next, which will be the rational function, finding the limit of a rational function, and that will be in the next episode. This is Gakpo Fred, your online teacher on Taxonomy Online Mathematics. Thank you very much.